Hi, welcome to lesson 8.2, writing linear equations. If you haven't done so already, you need to get your workbook. We're on page 4, but also I want you to grab your interactive notebook or something to write a couple of notes on because we need to take just a couple of notes. All right, writing linear equations. Remember that math is about representing real life. And so how things behave in real life. And that's what we're going to look at is writing a linear equation based on what's going on in a real world problem. Let's look at our notes though. A linear equation it can be written in several different ways, but what we're going to look at is it is a variable, and please, you'll need to write this down, but it is a variable equal to an expression with a different variable. So again, it is a variable equal to an expression with a different variable. It could be y equals 3x. It could be b equals 4a plus 1. It could be c equals 3d minus 7. But it's a variable by itself equal to some expression that has a different variable. So linear equations have two variables in it. Now, the variable that's by itself is called your dependent variable. And the variable that is in the expression is your independent variable. And it works that way every single time. So if I've got y equals 4x, y is by itself, it's your dependent variable. 4x is in the expression, so x is your independent variable. All right, you don't need to write this down, but so we've got y equals 4x, which is what I just used. Y is your dependent variable because its value depends on what x is. And I made a little t-chart over here to show you what I mean. When x is 0, y equals 4 times 0. So 4 times 0 is 0. So when x is 0, y is 0. When x is 1, y equals 4 times 1. 4 times 1 is 4. So when x is 1, y is 4. When x is 2, y equals 4 times 2. 4 times 2 is 8. So when x is 2, y is 8. So as you can see, a linear equation, once again, is a variable by itself equal to an expression with another variable in it. The variable by itself is dependent. The variable that is in the expression is independent. All right, let's look at our problems. We're going to do several together. I don't expect you to be experts on this because we are just going to, because this is brand new information. So let's look at doing some of the even ones. Let's look at number 2. Mrs. Boyle buys 2 pounds of beef. Mrs. Anand buys 1.5 pounds less than Mrs. Boyle. So Mrs. Boyle, I'm just going to write this out just so I know, is 2G. She buys 2 pounds of beef. Mrs. Anand buys 1.5 pounds less than Mrs. Boyle. So we're going to take what Mrs. Boyle bought, which is 2G, and subtract 1.5. That would be the amount she bought minus 1.5 pounds. Now we do this to help us with A. A says if the amount Mrs. Anand buys is D pounds of beef, express D in terms of G. When you've got this, express D in terms of G, that means you need to write D equal to some expression with G. So D is how much Mrs. Anand buys. Mrs. Anand bought 2G minus 1.5. So I'm going to put 2G minus 1.5. Okay? If you didn't quite get this, rewind it a little bit and listen to it again. All right, state the independent and dependent variables for the equation. I don't mind if you abbreviate like IND for independent, DEP for dependent. Now, do you remember the one by itself is which one? Look at your notes. Well, it's the dependent variable. So the dependent variable is D. The independent variable is the one in the expression. The variable in the expression is G. So what D is depends on what G is. All right, we're going to skip down to number 4. Raul spent B dollars for lunch. Dolly spent 1/3 of the amount that Raul spent. So let's look. Raul spent B. Raul is B dollars. Dolly spent 1/3 of that. So 1/3 of B is 1/3 times B, or 1/3 B. If C represents the amount Dolly spent, express C in terms of B. So because I've got that express C in terms of B, I'm going to put C equals. Well, up here it says C stands for the amount Dolly spent. And we wrote that the amount Dolly spent is 1/3 B. So C is 1/3 B. State the independent and dependent variables. All right, independent is in the expression, which is B. Dependent is by itself, which is C. All right, so we have written 2 linear equations to represent something going on in a real life problem. Let's look at number 6. Skip 5 and do number 6. The length of a square is P inches. The width of a rectangle is also P inches. The perimeter of a rectangle is 10 inches more than the perimeter of the square. The rectangle has a perimeter of B inches. Okay, let's work through this. So this is talking about perimeter. Okay. And the perimeter of the square. The perimeter is the distance around. A square has equal sides. So this side is P, this side is P, this side is P, this side is P. To find the perimeter, you add all the sides together. P plus P plus P plus P. Well, you got 4 of them. So the perimeter of the square is 4P. Okay. Then it says the perimeter of a rectangle is 10 inches more than the perimeter of the square. Well, if the square is 4P, 10 inches more would be 4P plus 10. Okay, so this stands for the perimeter of the square. This stands for the perimeter of the rectangle. Write an equation relating P and B. Okay, B is the perimeter of the rectangle. A rectangle is a perimeter of B. So B equals 4P plus 10. Okay. B equals the perimeter of the rectangle is 4P plus 10. Now complete the tables to show the relationship between P and B. When P is 2, B equals 4 times 2 plus 10. 4 times 2 is 8. 8 plus 10 is 18. When P is 4, B is 4 times 4 plus 10. 4 times 4 is 16. 16 plus 10 is 26. When P is 6, B is 4 times 6 plus 10. 4 times 6 is 24. 24 plus 10 is 34. When P is 8, 4 times 8 is 32. 32 plus 10 is 42. So what we did was we took a situation and made a linear equation out of it, and then figured out what the values were depending upon what P is. All right, let's look at 7. 7 is where we're 7 and 8 are where we are going to in Algebra 1. And I'm going to do most of 7 and 8 with you because it is pretty tricky. All right, it takes Sophia C minutes to cycle from the library to the mall. It takes 1/8 of the time cycling to travel the same distance walking. Walking takes W minutes. Write an equation relating C and W. All right, so there are two modes of transportation. There's cycling and walking. And let's read through to see what it says. It takes Sophia C minutes to cycle. So it takes C minutes. It takes 1/8 of the time cycling to travel the same distance as walking. I really kind of think this was a little bit mean to write it this way. Instead of saying it takes 1/8 the time to cycle as it does to walk, let's turn it around and say it takes 8 times as long to walk as it does to cycle. So if cycling is C, walking would be 8C. All right, then it says write an equation relating C and W. We can see that C is already in an expression, 8C. So we're going to write W equals 8C. Okay? W stands for how long it takes to walk. So we will, so where was I? So W, to figure out how long it takes to walk, we would multiply the number of how long it takes to cycle by 8. All right, so we're going to complete the table to show the relationship. When C is 2, W is 8 times 2. 8 times 2 is 16. When C is 3, W is 8 times 3, which is 24. When C is 4, W is 8 times 4, which is 32. When C is 5, W is 8 times 5. 8 times 5 is 40. When C is 6, W is 8 times 6, 48. When C is 7, W is 8 times 7, which is 56. All right, this is brand new about graphing. It says to graph the relationship between C and W on a coordinate plane. And this is the way it works. When you have a table in algebra, if the table is written correctly, this top is your independent variable, the bottom is your dependent variable. So C, this top one, is actually going to go horizontally on the horizontal axis. The W will go on the vertical axis. So whatever this is, we're going to put down here. Whatever this is, we're going to put over here. All right, so C stands for, we need to put numbers. C stands for cycling. And if I look at the numbers, I see that it is 2, 3, 4, 5, 6, 7. We're counting by ones. So we are going to, this right here is 0. And you're going to write 1 right under this line, 2 right under this line. We're going to count by ones because when we counted these off, these were counting by ones. 6, 7, 8, 9, 10, 11, 12, 13. So we're writing our numbers. 17. We are writing our numbers, and now we need to tell what these numbers stand for. And these numbers, remember, these are our C numbers, which are cycling in minutes. So we are going to write, these stand for how long it takes to cycle, or cycling, and write in minutes, because that's our unit. All right, let's see how we should count our walking. Now, if you'll notice this, we can't count by ones because we have to go all the way to 56, and there are not 56 spaces. So we need to figure out, how can we skip count? What units should we count by? Now, one thing I notice is all of these are multiples of 8, right? And so I think if we count by 8s, we will hit each of these quite nicely. So if this is 0, we're going to count by 8s. Right up here, this would be 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, and 88. And now we need to tell what these numbers stand for. These numbers stand for the minutes it takes to walk. So we are called walking. And write in minutes. All right. So now we graph our data. And our data says when C is 2, W is 16. So when we cycle for 2 minutes, so I'm going to come over to 2, we walk for 16. I'm going to go up to the 16 on walking, 2 for cycling. Those go together. When we cycle for 2, we walk for 16. When we cycle for 3, we walk for 24. So when we cycle for 3, we're going to go up to the line that is 24. Write that down or draw a dot there. 4 and 32. When we cycle for 4, we walk for 32. So 32 and 4. 5 and 40. Cycle for 5, walk for 40. And you can see that there is definitely a pattern going on here. 6 and 48, go here, 7 and 56. And you can tell that they would continue along here. Our table just didn't go on. All right, the last thing we do, this is a linear relationship, a linear equation. And that the reason it's called linear is when I graph it on a coordinate plane like this, it's going to make a straight line. So we want to draw a line. Also, when we graph, you have to have a straight edge. Get a ruler, get something that you can use as a straight edge. That is the rule when we graph, because I don't want some wavy line going through. Now, when we draw our line, we are not playing connect the dots. We are drawing a line all the way through. And it's very important that you line it up properly. Now, some people they put their ruler right on top of the dots. And if I were to draw a line, my line would not hit the dots. So you want to move your ruler slightly. And I know it's kind of why are we taking time to do this? But it's very important that you do. I want it, okay. I think they're all kind of sitting right on top of it. I'm going to start here and draw a line all the way through. All right, we have drawn our first linear equation. We have graphed it on a coordinate plane. Again, I don't expect you to understand. This is an introduction. D says to use the graph to find the time it would take Sophia to walk the distance if she cycles it in 44 minutes. I think that this is a mistake. Okay, so I want you to mark out walk and cycles. And we want to know how long it takes her to cycle the distance if she walks it in 44 minutes. And the reason I know that's a mistake is because it says use the graph. And if it's 44 minutes to cycle, our cycling only goes to 17 on our graph, but walking. So I think that the publishers made a mistake on this. And even if they didn't, we are turning it around because then you can't use the graph. So this is a mistake. This changed to cycle, this changed to walk. Use the graph to find the time it would take her to cycle if she walks it in 44 minutes. So we need to go to the walking and find 44. Well, 44 is not labeled, but it is on our graph. It is part of our graph. 44 comes between 40 and 48. In fact, 44 is right in the middle. So we're going to go right in the middle all the way to our line. Okay, so again, 44 is, I'm just going to kind of just like lightly draw a line there. And then we're going to draw a line down. Okay, Does that make sense? So 44 minutes would be about here. And then we go down, it's between 5 and 6 minutes. Well, how much time is right between 5 and 6 minutes? It's 5.5 minutes. So this would be 5.5 minutes is the answer. All right, let's look at number 8. We're going to do this one together too because it's brand new. Rachel reads P books and Malik reads 3 more books than Rachel. Let's write that down. Rachel, she reads P books. Malik reads 3 more than Rachel, so it's P plus 3 more. All right, together, they read H books. Write an equation relating P and H. So H stands for what they read together. So we need to add these together. P plus 3. Together, Rachel read P plus Malik read P plus 3. Now, from our last unit, you can see that this can be simplified. We can combine P and P. So I'm going to rewrite this in simplest form, which would be 2P plus 3. So there's your answer to A. B says complete the table to show the relationship between P and H. We've got 1, 2, 3, 4, 5. When Rachel reads 1, H, together they read 2 times 1 is 2 plus 3 is 5. When Rachel reads 2, together they read 2 times 2, which is 4, plus 3 is 7. When Rachel reads 3, 2 times 3 is 6, plus 3 is 9. When Rachel reads 4, together it's 2 times 4, which is 8, plus 3 is 11. And then I bet you can tell what this would be. All right, again, Rachel's books, this is your independent variable, this is your dependent. So we are going to make this H and this P. All right, P, what are we, oops, I didn't move it up far enough. So this top one always gets graphed here, the bottom one always gets graphed here, as long as our table is written correctly. And if you will notice, H is dependent. Dependent is on this side. P is independent. P is down here. I don't expect you to quite understand that or quite, but I'm just throwing that out there. Let's look at P. This is P. We are counting by ones. I've got a ton of problems here. I've got a ton of numbers. And we only go as high as 5. So 1, 2, 3, 4, 5. We would end there. Let's go ahead, instead of doing 1 for 1, let's put 0 here, but then skip 1 and put 1, just to spread out our graph a little bit. All right. And then H, what is H counting by? Well, H is counting by 2s. I only need to go up to 13 though. I wonder if we can count by ones. 1, 2, 3, 4, 5, 6, 7, 8. Oh shoot, okay. All right, this is what we're going to do because this is only 11, but we need 13. I'm going to draw a zagged line, okay? And what that means is this is nice and even. It goes 0, then we go 1, 2. This is spread out appropriately. This means we're going to start at a different place. I'm going to start at 5. And then let's see if we can do 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, let's just count by ones. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so now we've got our numbers for P that we got here. We got our numbers for H that we got here. And now we need to tell what these numbers mean. Well, these are our numbers that go with P. P stands for Rachel's books. So we're going to write Rachel's books. H stands for total number of books. So that's what we're going to write out here. Total number of books. And we're going to graph the relationship. So when P is 1, H is 5. So when I go to 1, I'm going to go up to 5, which is right there. Okay. When P is 2, H is 7. So here's 2, here's 7. When P is 3, H is 9. 3 and 9 is here. So when 3 and 9. When P is 4, H is 11. Here's 4, go up. Here's 11. So this is where they meet. And you can see a pattern establishing here. When P is 5, H is 13. There. Now we take our trusty and see how my lines are just kind of, my dots are sitting right on top of the line. All right, so there we go. Use the graph to find out how many books Rachel read if the total number of books read is 15. So I need to go total of 15. Wow, we barely got it. Here's the total of 15. We're going to go over and go down to figure out how many books Rachel read. Well, Rachel read 6. All right, class. That is how you graph and write linear equations. We did most of them together. I do want you to do 1, 3, and 5. 1, 3, and 5 on your own. Call me if you need help. Remember my office hours, and I will talk to you soon. Bye.